Activity 8.6. Take two paper bags or empty paper cups of the same size. Hang the two bags in the inverted position on the two ends of a metal or a wooden stick. Tie a piece of thread in the middle of the stick. Hold the stick by the thread as in a balance. Put a burning candle below one of the bags as shown in the figure. Observe what happens. Why is the balance of the bags disturbed? Does this activity indicate that warm air rises up? As the warm air rises up, it pushes the bag above the candle. Does the disturbance of the balance suggest that the warm air is lighter than the cold air? Can you now explain why smoke always rises up? Also, it is important to remember that on heating, the air expands and occupies more space. When the same thing occupies more space, it becomes lighter. The warm air is therefore lighter than the cold air. That is the reason that the smoke goes up. In nature, there are several situations where warm air rises at a place. The air pressure at that place is lowered. The cold air from the surrounding areas rushes in to fill its place. This sets up convection in air, as you learnt in chapter 4. 8.4. Wind currents are generated due to uneven heating on the earth. These situations are: A. Uneven heating between the equator and the poles. You might have learnt in geography that regions close to the equator get maximum heat from the sun. The air in these regions gets warm. The warm air rises and the cooler air from the regions in the 0 to 30 degrees latitude belt on either side of the equator moves in. These winds blow from the north and the south towards the equator. At the poles, the air is colder than that at latitudes about 60 degrees. The warm air at these latitudes rises up and the cold wind from the polar regions rushes in to take its place. In this way, wind circulation is set up from the poles to the warmer latitudes as shown in figure 8.8. The winds would have flown in the north-south direction from north to south or from south to north. A change in direction is, however, caused by the rotation of the earth. B. Uneven heating of land and water. You have read about the sea breeze and the land breeze in chapter 4. In summer, near the equator, the land warms up faster, and most of the time the temperature of the land is higher than that of water in the oceans. The air over the land gets heated and rises. This causes the winds to flow from the ocean towards the land. There are monsoon winds. The word monsoon is derived from the Arabic word mausam, which means season. In winter, the direction of the wind flows gets reversed. It flows from the land to the ocean. The winds from the oceans carry water and bring rain. It is a part of the water cycle. The monsoon winds carry water and it rains. Clouds bring rain and give us happiness. Farmers in our country depend mainly on rains for their harvests. There are many folk songs associated with clouds and rain. Sing and enjoy with your friends. If you know such a song, here is one for you. Roaring clouds across the sky tell us that monsoon's here. Dark and floating clouds in power, raindrops everywhere. Clouds make lightning flash overhead and irrigate fields with rain. Clouds make earth its fragrance spread. When wet with drops of rain rising from the ocean vast, clouds fill up with rain, rain to ocean, back at last, to mingle with ocean again. However, it is not always a happy ending. Rains often create problems. Can you list some of the problems? You can discuss the causes and solutions of the problems with your teacher and parents. In nature itself, there are certain situations that can sometimes create disasters and pose threat to humans, animals, and plant life. Let's study two such situations: thunderstorms and cyclones. 8.5 Thunderstorms and cyclones. Thunderstorms develop in hot, humid, tropical areas like India very frequently. The rising temperatures produce strong upward rising winds. These winds carry water droplets upwards where they freeze and fall down again. The swift movement of the falling water droplets along with the rising air create lightning and sound. It is this event that we call a thunderstorm. You will read about lightning in higher classes. If a storm is accompanied by lightning, we must take the following precautions. Do not take shelter under an isolated tree. If you are in a forest, take shelter under a small tree. Do not lie on the ground. Do not take shelter under an umbrella with a metallic end. Do not sit near a window. Open garages, storage sheds, metal sheds are not safe places to take shelter. A car or a bus is a safe place to take shelter. If you are in water, get out and go inside in a building. How a thunderstorm becomes a cyclone. You know that water requires heat when it changes from liquid to vapor state. Does the water give back heat when vapor condenses into liquid? Can you really any experience to support this? Before cloud formation, water takes up heat from the atmosphere to change into vapor. When water vapor changes back to liquid form as raindrops, this heat is released to the atmosphere. The heat released to the atmosphere warms the air around. The air tends to rise and cause a drop in pressure. More air rushes to the center of the storm. This cycle is repeated. The chain of events ends with the formation of a very low pressure system with very high speed winds revolving around it. It is this weather condition that we call a cyclone. Factors like wind speed, wind direction, temperature, and humidity contribute to the development of a cyclone. A structure of a cyclone. The center of a cyclone is a calm area. It is called the eye of the storm. A large cyclone is a violently rotating mass of air in the atmosphere, 10 to 15 km high. The diameter of the eye varies from 10 to 30 km. Figure 8.11. It is a region free of clouds and has light winds. Around this calm and clear eye, there is a cloud region of about 150 km in size. In this region, there are high speed winds 150 to 250 km per hour and thick clouds with heavy rain. Away from this region, the wind speed gradually decreases. The formation of a cyclone is a very complex process. A model is shown in figure 8.11. 8.6 Destruction caused by cyclones. Cyclones can be very destructive. Strong winds push water towards the shore even if the storm is hundreds of kilometers away. These are the first indications of an approaching cyclone. The water waves produced by the wind are so powerful that a person cannot overcome them. The low pressure in the eye lifts water surface in the center. The rising water may be as high as 3 to 12 meters. It appears like a water wall moving towards the shore. As a result, the sea water enters the low-lying coastal areas, causing severe loss of life and property. It also reduces the fertility of the soil. Continuous heavy rainfall may further worsen the flood situation. High speed winds accompanying a cyclone can damage houses, telephones, and other communication systems, trees, etc., causing tremendous loss of life and property. Tornadoes. In our country, they are not very frequent. A tornado is a dark funnel shaped cloud that reaches from the sky to the ground. Most of the tornadoes are weak. A violent tornado can travel at speeds of about 300 km per hour. Tornadoes may form within cyclones. The whole coastline of India is vulnerable to cyclones, particularly the east coast. The west coast of India is less vulnerable to cyclonic storms both in terms of intensity and frequency of the cyclones.